Good morning, everyone. Welcome to the third and final day of the HPC onboarding course. Thank you for your participation. I hope you enjoyed the last 2 days. So since we learned how to schedule jobs on HPC and how to transfer file, we will continue the learning today. We will continue the how to access software and about the quota and storage on the HPC, as well as how to use the resources with the shared resources responsibility and how to ask help when you encounter any issues while working on our clusters. That we will cover today. And as just like the last 2 days, I would like to remind you that we are recording this session, as you can see, and please feel free to close your cameras, switch off it, so that we can process the recording properly. Anyway, we will be editing the videos before publishing it on YouTube. And just a kind reminder that we follow code of conduct, both the instructors and the participants. So it's mostly like being yourself as you were last 2 days, being respectful to each other. And can you share that collaborative document, Björn? Just like, yeah, thank you. Just like last 2 days, we use the same collaborative document to ask questions and give answers and any kind of interactions. The last 2 days Q&A are archived and linked on this page. You can go back and revisit these answers. There are some answers I finished after the event yesterday, some questions regarding the project application and all. So you are welcome to revisit this archived collaborative document from the last 2 days. Just like last 2 days, we have an icebreaker question for today. Please go ahead and write which software would you like to run on our HPC machine, or most likely what is you are doing with what kind of software you are using your day-to-day work. That I hope that would be the one you want to run on our HPC machine. And I just want to mention that we really like that you interacted the last 2 days on this collaborative document with lots of questions. That was very fun. And we feel that it was very interactive, and we would like you to continue that same pace and ask a lot of questions. And we have a lot of people, many people from NRACE training team to answer this question on the collaborative document. And please go ahead and ask a lot of questions. Yeah, thank you so much for the participation, and thanks to the instructors. Without much delay, I will give this Zoom dice to Björn, who will lead the software access session on with Sabri, right? Okay.
Yes, Daniel.
Yes. Thank you.
Yeah.
Go ahead, please.
Good morning, everyone. We'll start today with discussing how to use software on the HPC system, or how to access software. And we will also be doing an exercise with respect to accessing software. So let's dive into today's lessons. Let's see here. It's some background noise here because people at my office are talking, so I apologize for that. So we will discuss how you can find software on an HPC cluster. It's software are installed different places on an HPC cluster. You have different types. You have the software that comes with the operating system, which is installed in one place. And then you have scientific software, which is installed by NRACE, and it's installed in another place and accessed by other methods. So we'll look into this and understand how the Unix system looks for installed software. So commands that you will be using is module avail, module load, and module purge. These are for searching for software, load software, and unload software. Have you anything to add, Sabri?
No, Bjorn, sounds good. And why do we have to learn this?
Why do we have?
Why do we have to learn about these modules and etc.? Can't we just use our software directly?
If you only have your own software, you can install it on your home area and then go ahead without the module system. But if you're like somebody says they want to use GrowMax, then you need to know how to use the module software. And also for R packages and like bioinformatics software and such. Then it's necessary to learn about the module software.
Yeah, in that case, I'm looking forward to learn this.
Very good. Pay close attention then. So when you log in, you have your home area and you have the system's installed software. It's really that you have the software that you need available at once if you haven't done any modification. So you can configure your home area to have all the software you need ready for you, but that takes some steps. So we say that we need to load the software that we're going to use. So, but before we start using individual software packages, we should understand how these are approached and how these are built up. And this goes for have to try to understand software incompatibilities and versioning and dependencies. Software incompatibility is a major headache for programmers. So sometimes software packages break because there are incompatibilities. Software versioning is another common issue. A team might depend on a certain package version for their research project. And if the software versions change, it might affect their results. So having access to multiple software versions allows a set of researchers to prevent software from affecting their results. So as we will see when we list the software installed on Saga, that there are often several versions of the installed of a software package. Dependency, yes.
Bjorn and Sabri, could you give an use example of have you ever experienced this compatibility issue or?
Yes, this glibc underscore 3.4.20 not found is a nasty incompatibility that I experienced several times. That you have software that this comes from the version, the glibc version, and if it's not proper, it will give this error, and it affects some very basic software.
Okay, thanks.
How about you, Daniel?
Yeah, I experienced something, but not regularly.
No, hopefully not regularly. We don't like it to happen regularly.
So I use modules most of the time. I don't really install things on the HPC as a user.
And then we have dependencies. dependencies are where a particular software package depends on having access to another software package. So we will see this as well, that we can get long dependency lists. For example, the VASP material science software may depend on having a particular version of the fastest Fourier transform in the West and other packages. But let's first have a look at globally installed system packages. You can type after me and see if you get the same results. I'll clear my screen here. We can test the Python command and see what kind of version we have of Python and where it is installed. We see this with the which command.
Björn, should we try this or what
yeah,
you're doing?
type after me, type alone, so you get a feeling of how to do this. So Python -- version gives 3.914, 3.914, and the which Python says that this is the Python version installed on the system level, in the user bin catalog or user bin subdirectory. User bin subdirectory, that's systems software, and you're not able to install any software there. It's only the root, those with the system administration privileges that can install system software. Then we have the command Python 3. So let's look which version that is. Yes, it's the same version. Which Python 3. It's also installed under user/bin. So we can conclude that Python 3 and Python is the same executable. And we see that writing user bin, we can write the full path for accessing Python, or we can write just the Python 3 command. This is equivalent. And the reason for that this is equivalent is that we have an environment variable called path in our shell. So if I do echo $path, we get a long list of subdirectories divided by colon. So you see when I write Python on the command line, the shell will search first for Python in cluster home Bjorn Lin local bin, and then in cluster home Bjorn bin, and then it goes to node bin and until it comes to user bin, where it finds Python. So in this way, we can have also, you see that I have local subdirectories in my home area, and these can then override system settings. So I can have my own Python installation, for instance, in local bin, and then that will become my default Python installation. Do you have anything installed like this, Sabri, in your local area?
No, I don't have any software that installed on my home area, but I have some packages, for example, pip packages in my home area. And because I see that in your path, like if I log in, I see with my username, my path is already the path for my home is already there in the path, which means the computers on the HPC computers would be able to find my Python packages as well.
All right. Okay, there's an exercise. We'll jump over that one. We'll have an exercise at the end of the session. We'll now look into environmental modules and explain what module is. So a module is a self-contained description of a software package. So it contains the settings necessary to run a software package, and usually encodes required dependencies on other software packages as well. So there are different types of module implementations. And we use the L mod on Saga. And it starts with a module command. So if you write module list, you get a list of all the software packages that you have installed, which is not much. We haven't loaded anything. So can you explain the standard N with the S, Sabri?
Those are some standard sets of libraries that are needed for general functions. You should always have them, and those will not affect the modules that you're going to use.
All right. So I'll go on finding and listing available modules. So let's search for the software with the bio installed. Module keyword bio. Then we get a long list of software, which is bio has the bio keyword. Like Mira here has pack bio. And this is the bio software that's installed on Saga and are available for us to execute. A lot of packages. And other command we can use is module avail. This lists all the module software that's available. Module avail. So we see that there's quite a lot of packages installed. And most packages have several versions. Or like SciPy bundle here has several tool chains that's installed with. I'll explain that in a moment. R comes in several versions, as well as Python. And all these packages are maintained by Inris and upgraded upon request as well. So if you have a package of that you want to use and you want to install it in the module system, you can ask for it from the support system. And we try to accommodate for everybody, so we try to install if it's possible. We can also use module avail for asking for specific software. So in contrast to the module, by using module avail and the software name. So in contrast to the module keyword, it searches for just the module name and not in the metadata, not in the descriptions. So let's see here, if you write module avail Python, we get all the packages that has Python in their name, which is quite a few. So how do we use the software? Well, we use it by using the command module load Python 396 GCC core 1120. And that took a second. And which Python is on our path now? It's the new 3.9.6 that's available to us. So now
so we are if you are on a login machine on you're on a login machine on Saga, and you load a module. Would that affect me? Like if you load some module, would that modify what I see?
This don't modify what the other sees. It doesn't modify the compute nodes, and it doesn't modify other sessions that you have. It only modifies the shell that you're currently working in. So if I exit this shell now and log in once again, I need to do module load Python 3.9.6 and so on to get access to this version again.
So because of there are so many software versions and softwares, and there are so many users with different needs, so this system allows the HPC system, the service providers to help them all Like if you install Python 3 one version, then someone might need some other version. Now in this way, safely people can switch and select, mix the software they need.
Yes, that's right. Yeah, we can take a look at the path, how it's been modified. Echo $. Path. So we see the path has grown significantly, and that is because there are several packages that are loaded as well together with Python. So if you take a look at the software in the module subdirectory, you should see the just these Python installation. It was bin. So module load will add software to our path. So it loads the software. A special note on this, depending on which version of the module program is installed, the module will also load the required software dependencies. So we can see the dependencies with the command module list. And here we see that we started with the standard end and nothing else. And then we have gotten GCC core, setlib, and a lot of packages before before Python 3.9.6 is loaded. So Python 3.9.6 are dependent on all these packages. So if we now want to get rid of, we want another version or another software package, we can clean the environment by the command module purge. This will remove all the packages from our or unload all the packages from our environment. Module purge. So module list. We're back to start with just the standard and as a load of the module. And then again, we can load a new module, loading blast this time. So it's unknown. We didn't run this command before the lesson. Then. So let's see if we have blast in another version. last. So we have 211.21a. Module list. And then we have now these packages loaded. So now we have changed our working environment completely. So if we also have the module command unload. So if you take module unload last 2.11.0 Gumpy 2021a, we succeed with that one. And then we just have removed the 23rd package. Most of the packages are still there. It's just the blast package that we removed. So module purge again to clean out everything. And we see that module purge inform us that it's just a standard end module that's available. Have you anything to add, Sabri, to what we have seen so far?
No, not specifically, but regarding a question in the shared document. So these module systems that we provide are part of the service. You know, the engineers, they install software, but how to use this software is not part of this module system, which means that if you load a specific module, so here the example is that GATK, GATK software. So how to use that software is up for the researchers or the users to find out how to use that software. But on our side, we have installed GATK and made sure that all the Java home and everything else that's needed to use the software is installed. If your question is scientific, for example, how do I perform this specific analysis using this software, is not specifically part of the service that we provide. But if you need such a service, then you could ask for an advanced user support, which is another level of support. And when you show this BioPython and all those modules, so they are at your disposal. You know, if you know how to use them, you could load them and use it. And the module command will not tell you how this software is used for your scientific work. Is that does that make sense, Bjorn?
That makes sense. So let's discuss software versioning and tool chains. So far we learned how to load and unload. So this is very useful, but we haven't discussed the software versioning. So at some point, you will run into issues where only one particular version of some software will be suitable. Perhaps a key bug fix or only happened in this certain version, or version X broke compatibility with the file format you use. In either of these example cases, it helps to be very specific about what software is loaded. So here is module avail for Python. So you can see that module avail lists 6 versions of Python, with the version number being first after the slash. And the GCC core describes the tools change with which Python was compiled and its versions. So the different Python versions are compiled with tool change from GCC core version 10.3 to 13.20. So tool chains are standardized bundles for installing modules. So there are the most common ones are GCC core, Intel, and FOSS. So it's important to know that modules created with different tool chains are often incompatible. So you can't mix and something that's built with the Intel tool chain with GCC core. But the module system helps you with this and will give you an error message if you try to load incompatible versions. So so you should also always try to find modules with matching tool chains whenever you need to load more than one application. And we saw that when we loaded the Python and you did module list, that it was GCC core tool chain that was loaded for all the necessary packages. Okay, so how do you use this in how do you load modules in scripts? Let's do a test. Write a batch script that runs in the queue. Nano Python module shell. I already have it. So if you copy the text and paste it into the Nano editor, make sure that the account is NN9970K, and then Control Exit. You will be asked to save it. And then we can run the batch script, batch Python module. So it's submitted. So now it should be finished. Less slurm. 1140. So though it's a lot of text, we see that it prints out the version number of Python. So this is how I get access to Python on the batch system. Okay, so now there's an exercise for you. Before we go to the exercise, is there any questions in the document? What if I install Emacs instead of using the module system? Yeah, so the module system is mostly meant to be scientific, for scientific software, and not editors. What's the difference between globally installed and software and the module system? The globally installed software you don't have to load, so you don't have to do the module load for having access to it. It's available once you log in. Yes. So by default, are all software stored in a bin? Well, it's use a local bin, something with bin. But for bin is for binaries. In the example, Python and Python 3 have the same version. Is the program duplicated, or does it refer to the other? How can I check this? Yeah, so you can do the ls-lhi and then see how it's soft linked. So what happens exactly? Sabri, do you remember the command that shows what you do to the environment with module load? Module load info or module load?
No, I don't remember. We'll find it and place it in the shared document.
I think so. Yeah. We can do that. Oh, it's probably time for exercise. So we have 15 minutes exercise. Starting now, that will be ending at 9:58.
Yeah, hi everybody. So, Radovan Bast, University of Tromsø. In contrast to 2 days ago, today is raining, not snowing. And I'm really looking forward to talk with Tanya about something that is really important to understand Quota, how it works, why we have it, and how to recover from typical problems. So we will work on this session here. In the collaborative notes, I have also pasted links where you can follow along or read up more afterwards. I will first go into this overview page here, but very soon we will switch to the terminal and we will try some of these things live. The best way to participate will be to watch what we do and to ask lots of questions. I will be watching this document. Tanya is watching this document. The more you ask, the better the session will be. I will now go into the first link and open it up. And I want to discuss this overview really briefly. So we want to talk about compute quota and storage quota. I think we will start with storage quota because it's maybe the one that is a little bit trickier. And why do we have quotas? So we have limitations on how many files you can create and how much disk you can write to. And why do we have these limitations? Well, because I think we are 2,000 users on our national systems. And we need these limitations. Otherwise, I could accidentally fill up the disk. Maybe I make a mistake in my command, I fill it up. And then all the other 2,000 people will be really unhappy. And to prevent that, we have this quota in place. So this is not to limit your work. This is just to make the system more usable. And let's start here with, we try to give you an overview here over the different storage areas. And we will see, and maybe this has been mentioned before, that we have 3 spaces, sometimes more, but very often we have these 3 spaces on all our clusters. One is the home, one is the project space, and one is that sometimes we call it work or scratch. And the home has very limited quota, and we will experience it. And it's good for scripts. It's good to keep your run scripts there, small data files, source code. It's backed up, hopefully, but please check when you log into the cluster. There is normally a message that tells you whether this is backed up or not. And guess what? I will demonstrate to you how you can fill it up, and I will demonstrate to you how it looks when it's full and how you can recover from it. And then there is the project space. This is really there is much more quota, much more space. This is the place where maybe this is where you want to keep your calculations. If you do Conda installations, if you install your own software environment, you want to install it into the project folder, not into your home folder. And then there is the workspace, work or scratch. It's basically unlimited, gigantic space, but it comes at a price, and the price is that the files which are there, they automatically disappear after a time. I think currently it's 21 days. Sometimes it's 42 days, depending on how much space we have.
There is one correction, like when the file system is full, more than 90%, it will reduce to more 18 days. Nowadays, Betsy has reduced automatically days for automatic deletion because the file system is kind of 95% used. It is because we want to have the file system in under 90% usage so that users can better experience on the cluster.
Yeah. So this comes as a surprise to many. It's automatically deleted after a while, 2 weeks or 3 weeks, depending on how full the system is. It's good for temporary files. It's good for testing. If I want to test something out and I don't need these things anymore in 3 weeks, then I go on work. But for anything that you want to keep, make sure that you copy after your calculation is done. Make sure that you copy it back to either the project or the home if you want to keep it.
Or transfer to your laptop if it's a post-process data that you need.
Yes.
One thing, this cluster work is not backed up, and if it's automatically deleted, means we cannot recover it. Even though if you ask for us to recover it, we get some questions sometimes that the user want to recover the data deleted from the work. We cannot do anything on that.
Yes. Good. No new questions, but I'm looking at them. How about I switch the screen and I go on Saga cluster and I will try to make some mistakes and I will try to recover from them. And exactly about this storage quota. So let me switch the screen to just want to make sure I share the right thing. I think it's this one. It's a pretty empty looking terminal. I'm on Saga. Here, don't type with me because I will actually make mistakes. And so here, just watch what I do and ask us questions, comment on what I do. And we were used to see this history window of past commands. In this time, we will not see it because I actually broke my system so badly that I cannot even have that. And we will understand why. Let me try something. I'm in a folder called example. What is in there? There are some files. There is some scripts and some run script, and now we don't even need to look into those, but I want to create a new run script. And I expected I might see an interesting error message. Some copy one file to another. What could go wrong? Enter. And this is what I see. This quota exceeded. I wanted you to see the error. I wanted you to see how it looks. And I wanted to show you what I do when I get that error. So it happens in the best families. It will happen to you to fill up the quota, but not a problem. We will now diagnose it. So the first thing I do when I see this is to type a command called deusage. It is a little program that we have written. So this is not something that is available on every Unix system in the world. It's something that we have written and it runs on our systems. Deusage, enter. And okay, a little bit hard to read because I have big font. I will zoom out a little bit here. It will make the font smaller, but hopefully it makes it easier to read. Not sure this is still readable, but can you see what the problem here is?
Yeah, there is something on red.
Yeah, so here red color, alarming. Here yellow color, probably a problem soon, but not yet. Here we have a problem. And this tool informs me about how much space I have used and how much space I have available. It also informs me how many files I use and how many files I have available on the various places. So this is the home place. And these are the project places that I mentioned. I'm part of 3 different projects. This one is the one that we use in this course. And then I also told you that there is this huge, almost unlimited looking work scratch. And there are no limitations there. But the problem seems to be here. I have filled up my home. My quota is 20 gigabyte. I have filled it up with 24 gigabyte. And now it doesn't let me do anything on the file system. I cannot create new files. I cannot copy them. I cannot modify them. Before I can do anything, I need to free up the space. And before I do that, I wanted to show you one useful command, because now maybe you are not sure, like, where in my home did I fill it up? And I will use this command, which I shared on the collaborative notes, which is not in our documentation, but it will be a nice recap of what we learned 2 days ago. So one useful command is disk usage. How much of the disk am I using? -h, I want it in human format. And I don't want to go through all my files. I only want to see my folders. So it's max. So there's a command called max depth 1. I will make it a bit larger. Enter. And now it lists something. I will go a step further and connect it to what we learned about composing commands. I will pipe this into sort in nice human readable form and in the reverse. Enter. You don't need to remember the command. I just wanted you to know that you know it exists. Here it lists me all my folders in my home folder, and it will put the largest one on top. So there is a problem. I created a folder called large files accidentally in my home with 19 gigabyte, and I filled up my home quota. ls-lh. So I have a couple of really big files here. Each is 4.7 gigabyte. Question 28, what would happen if you try to touch a file? If I try to create an empty file, let's try. Touch, empty file. Oh, not even that. I cannot even create an empty file. And that is because in Unix, empty files are not really empty. There is there is the empty file, but there is also a little, it's like a library card that tells the file system where to find the empty file. And that one takes a little bit of space. I'm not even able to do that. So you might not even be able to log in, depending on how you log into your system, because some login mechanisms actually create a little tiny file on the home folder. You might not even be able to log in, and then you need to contact us.
Yeah, and on commenting on this, Radhavan, even though if we'll have storage on project area, we cannot do it since we fill up our home quota, right? Or
you mean to write this, to do this thing on the storage on the project?
On the or any like simulation on the project area, like if you go there and work it, is it working? Will it work or?
It should be possible. I can try that.
Yeah.
Now I don't remember where is my project area. I will ask the usage. It's this one, for instance. I will navigate to it. And now you also understand why I don't show you this history window with past commands, because I'm not able to even write to my history. But I will go there and I will create a folder called experiment. And in there, I can actually touch empty file. Here I can create files, I think. And on the project folder. But now how do I recover from it? And that confuses lots of people, because they see this, they see, oh yeah, there's a problem. I should move these files to the project folder. So let me go back to my home folder. Make this larger again. Let's go back to these large files. So here, whoops. Here they are. You might now think that, well, to recover from it, let's just move all of these large files over to the project folder. And that is not the right solution. Well, it's part of the right solution, but it's the right solution, but it will not solve it. Let's try it. And all of this, everything that I do here is in the documentation, so there's nothing you can read up on it. But I will try to fix the problem, and we will see it will not quite fix it. So if I move this large files directory to the project folder, to this one, enter. Now they are not in my home folder anymore. They are in the project folder. And let's ask the usage again. Is the usage happy now? Can I now create files and folders? So one thing that really surprises lots of people is that even if you move the files, they still show up here. How come they show up here? Why don't they show up in this place? And this is because on Saga and on From, the quota is based on ownership. It's not based on location only. It's based on location and ownership. So if I want to fix this, I will go into the project folder. I will go into the place where I moved them into. So they are here. The problem is that, and I think there's a question or comment. Please ask. Yes.
Just continue with your sentence and I'll ask afterwards.
Yeah. Okay. So what I want to say is that the thing that is a problem here, and we remember the very nice presentation 2 days ago by Maiken about ownership of what is the user ownership, what is the group ownership. And the group ownership this is my group. So these files will still count to my home quota. And if I want to fix it, I need to fix this ownership. And then this will become not be read anymore, and then I can create new files. Yes.
So what I find confusing about this is that if you remember the permissions and making things executable the first day. There was like in the project folder, I don't think we talked about that, but there is an S in the, if you do ls-lh on the project folder, you will see that there's an X in the permission.
Here, I will try that.
And I thought that that S means that whatever you write into that folder gets owned by the owner of the group of the folder, which is NN990K.
Yes.
So it's surprising that when you move the files, the ownership doesn't change.
To me, it was also a surprise, and I'm not sure I can fully explain it. And maybe there is an option to move that you can move. So maybe there is a way to do this more automatically. I was also surprised by it. And indeed, what you said is, so if people remember, I created this directory experiment, and I wrote an empty file into it, and it created it with the correct permissions. But when I moved files, it kept the permissions.
Okay, so maybe it maintains permissions if there are already permissions, but if you write new files, it gets the, that could be.
And maybe there's a better way to set it up, but this is the way it is set up. And now if I want to fix this, I need to fix the ownership of this. And I know how to do it. I just want to make sure that I do it the way we document it. I will just open up in my little side window because I think I'm used to one way of doing it. I just want to make sure that I do it. Do we do change group, right, in the documentation? Maybe I can show both ways. Yeah, so in our documentation, what we advise to do is there is a command called change group. And I could do it like this, large files. And I think I need to give it an option to do it recursively for not only for the directory, but all the files underneath. This is one way. The other way is, and this is what I'm more used to, is to change ownership. So I'm personally more used to this because in my muscle memory, I do that. Both will do the same thing. So here I change the ownership to me and this group. But let's go back to how the documentation is, because I want to try that this is really working. Change group, the directory large files, and everything underneath to this project group. Ooh. Why? That's interesting. Anybody here? Any other experts know why that is failing on me?
Aren't you in large files folder already?
Oh, I'm in there. Aha. Yes, thank you. So let's go one level up. Thanks. Let's try that again. Boom. And now the ownership is okay. And now if I ask the usage again, it looks much better. And now I will try to demonstrate that it works. So back to my home, back to example. Let's zoom in. What was here? There were some files, and this is what I wanted to do a long time ago, to copy this into another file. And it still complains. Whoa, why is that? And that is because there is a bit of a delay between the quota information and what I'm allowed to do. So if I would wait now 5 minutes, 10 minutes, depends on how the file system is busy, I will be able to write again. So if you did the things right, and here it looks right on top, no red color, and if you still get this error, give it a few more minutes. The information just needs to go through the system.
Radovan, there is a question about question 31. Does the move really happen physically? I assume it's like if the move happened to the new folder. That.
Oh, sorry, which function is that? Can you?
31.
Does the move really happen physically just after typing the command? So when you do a move on, on a file system, it actually doesn't. Okay, it depends a little bit how. So on the file system, there can be sort of areas, so-called partitions. And if I move a file from one partition to another, it would actually physically copy all of these magnetic bits from one place to another. If I'm on the same partition, and here I admit actually I don't know whether we are on the same partition or not, it might not even need to physically move the magnetic bits. It only needs to change the information where it is. So here there was 20 gigabyte and I type MV and it was really quick. It took like a few milliseconds. So I would guess it didn't really have to do anything. It only had to change the location.
Correct me if I am wrong, because I found it like when you move, you consider this as an envelope with a stamp on it, and you move it to the other folder, but you didn't change the stamp so that the ownership is in the same. If you change the stamp only, then ownership changes. Would it a nice explanation about this changing ownership?
Yeah, I think that's a nice analogy. Yeah, I never thought of that. Yeah, nice analogy.
Yeah, it just came now. So
yeah, I like that. Okay, now we have 15 minutes left. I can show you some more mistakes if because another really popular mistake. If we have time, and then we can talk about the project quota. But that is maybe the project quota is maybe more intuitive. Good. I will now go to a different machine. Again, just watch. And the reason I go to a different machine is because messing up one system in two different ways was difficult enough. I will log out of Saga. I will go on one of our other clusters. But the same thing I could also demonstrate on Saga. But I will now go into, so how was that? My username from sigma2.no. And now we have the history window here. So this is a different cluster. Don't type with me. I will create a different popular mistake and we will fix it. We will diagnose it and fix it. And here, the usage. Do we have the usage on this system? Yes, we have. And hopefully this is not too tiny. The thing that I will now try to do is I will try to focus on this part here. I will not create a lot of data, but I will create very many files. In my home, I have now 43,000 files. And in Unix, we call them inodes. And it's not exactly the same thing, but it's approximately the same thing. And maybe just to tell you what an inode is, I will switch the screen to a Wikipedia page, just for fun. And then I will switch back to the terminal. And here I'm looking at the Wikipedia page for a library catalog. And this is really, for those of you who have gone to a library in the 1990s, if you are younger, you need to maybe go to a museum. But if you went to a library earlier, today, if you go to a library, you go to on the webpage and you search, is the book available? You don't even have to go there physically. But what we used to do 30 years ago is that we went to a library and then there were these catalogs. And if you wanted to know, where is this book? Do we have it there? It will be, I would search in these little cards. And the little card will tell me that the book that I'm searching for is on the second floor, the third corridor. It will tell me where I can find it. So a nice nostalgia moment for those of you who remember. And why did I show this? Because this is really very much how the file system works. And these inodes that I mentioned, just think about these little library cards. And now let's go back to the file system and let's look at these library cards. Here, back on from, because when I talk about quota of files and limitations, we have a limitation because we cannot have infinitely many of these library cards, and we limit you there to 100,000, actually 120,000. So there is a hard quota here and a soft quota. Maybe we can talk about it later, but there is a limitation of 100,000 of these little library cards in your home, because if we would allow you to have 1 million or 1 billion, it would really slow down the file system. So we have this limitation again to make the system more usable. And now what I will try to do, I will try to break my folder, because I will try to fill it up. And I will try to do that with something that it's very easy to do if you are not very careful. I will go into an example folder. Oh yeah, I actually wanted to show you these library cards. So there is a run script. I might come back to it. But something you can try later on your home folder is ls-li. It's a command that we haven't seen yet. And it will list you inodes. So this is the number of a library card. Each of these has a number, and then the file system can look at this and find out where is the file and retrieve it. And what I will try to do now, and this will nicely connect to the accessing software part from earlier, because what if you don't, I need to use the software, it's not available, it's not in the module system, and now I read on the internet that I can install it into something called a Conda environment. And if this is a new thing, we have other course material on how to install your own Python packages and R packages. Here I will install a couple of Python packages. And Tanya, just can you confirm that I'm really sharing the from terminal right now?
Yes, you are.
I will now create two files. And here I will follow our documentation on how to install Python packages, but I will make some mistakes in that. And first I will create an environment file. So don't worry about what I'm doing precisely. I'm just trying to install a Python environment. In one of these files, I will describe it. So here I describe the environment that I want. And here I'm copying an example that it is in one of the links that I put on the notes. But don't try it now, because I don't want you to mess up your system. I want to install my project, and it lists a couple of dependencies. These are Python packages. And this file that I just created, it's a good way of creating Python environments. I want to now create my own Python environment. And I will install it with a script. And this script doesn't exist yet. I use this vi command here. It is my editor. This is how I edit files. But it's not the essence here. The essence is that I will copy an install script from our documentation. So our documentation says that if you want to install a Python environment, this is how you can do it. But I will make a mistake here. One change from the documentation is that the documentation says something like module load conda anaconda and then something. I changed this to Mamba, that's fine. And this is just to speed it up. Mamba is a really fast way of installing Python packages. But I made a little modification here, because the documentation recommends that please don't install this stuff into your home, because you will fill it up. So here should be really a project folder. This should not be the home. But I will just make a mistake here. I will tell it to please install it into my home. And guess what will happen? We will probably fill up my home quota with too many files. And I want to show you how easy it is to fill up your home quota with too many files. And this stuff I copied from our documentation. It's a way to install this Python environment. And this installation will be very brief. It will take a few seconds only, hopefully. So I will run it directly. And this will nicely connect to the next session when Espen will tell us about responsible use. So I will now be not completely responsible. I will run it directly on the login node. And later we will hear whether this is really a nice way of doing it or not. I need to make my script executable.
Another one, can I just break in 2 seconds?
Mm-hmm.
Don't delete your history, because it would be nice to grab your history and make it available for the participants later, okay? So
Good
don't
point.
log
I will
out
then copy the
afterwards.
history to everything I did to the
Yeah.
notes. I have a to-do list item. Thanks for reminder. So there was now a lot of back and forth, but the long story is I'm installing some Python packages, but the mistake I do here, I install them into my home, not into the project folder. The other mistake I do is I run it directly on the login node, and we will hear more about it later, but this will only take a few seconds, and hopefully my colleagues are not too upset at me. Okay, now we can lean back and look at questions. I'm just hoping that this will really work. What do dependencies mean? Mm-hmm. Would it be okay to run commands like scp on the login node? Yes, absolutely. So editing files, copying files, submitting scripts, and doing very short installations. And here, this is a very short installation. It will take less than a minute. I think anything that takes more than a minute, or more than a few minutes, I would not run on the login node. But one nice thing I did is I put the installation into a script so that if I want to remember how did I install it, it's in my script. And now it's installing packages, lots of Python packages here, but nothing out of the ordinary. All I ask for are a couple of very popular packages like SciPy, Matplotlib, NumPy. So if you work in Python, then these probably sound very familiar. And now they are being installed. They are being downloaded and installed, and in a couple of seconds, I expect a problem. And the problem I expect to see is that I fill up my home, not in terms of space, but in terms of number of files. And the recovery there will be to delete my environment and install it again somewhere else in the project folder, ideally. And while we wait for this thing to install, I'm looking at questions, but please also help me erase some that didn't get enough attention or in voice. Oh, it did work. Interesting. But now let's ask the usage again about the situation that I'm in. Oh, you see, red color. I have now 107,000 files in my home. It was easy to create 100,000 files. It's above the so-called soft quota. So on some clusters, you have a difference between the soft quota and the hard quota. The soft quota means is that, I don't remember actually the definition, but for a certain amount of time, for a few days, I can still create new files. But after a certain time, I will not be able to do that. And I don't know whether the time is a few days or a few hours. I don't remember. But if I go above the hard quota, I will not be able to create any new files. And
also backup will be stopped if you go beyond hard quota.
And now I want to copy one more command that is in our documentation, but I will also then list it, which it's a long command. And this is a long command here. Find lots of options. I don't remember this. I copied this from the documentation, pipe it into something, pipe it into something. But this is what I run if I have too many files and I'm not sure where they are. So you'll find it in the documentation. I will put it in the notes, but let's see what the output is. And Sabri has a comment or question.
Yes, Radhan, one comment that I saw several times when answering user support cases is that the project folders number of files increase and the project folders the quota exceeds, but I didn't like the person who's asking the question did not do anything. It's just the colleagues filled it up. So I see that you have this yellow number 932. Maybe you can comment a little bit about, like, although you might not be the person who filled it up, maybe if you're part of a project that might affect you.
Yeah, that's a very good comment. So here 2 things are left, and I see we have 3 minutes left, but we'll manage. So one comment now was that here, whatever I do, it's on me. That's my space. If I fill it up, then I messed up. But here with the projects, I'm with other people. This is now our training project. Here we are with, well, 40 people. So maybe this wasn't me, maybe this was my colleague. So here we have to talk to each other, talk to my project colleagues, and maybe I should tell my colleagues from this project that maybe we can free up the space. Is there anything that we don't need anymore, so that we don't run here over quota? Because if I run over quota, my job will not be able to write anymore to the disk. And it's really annoying if my job was running for 2 weeks on lots of processors, and I was patiently waiting for the results, and then before writing the final result, quota was full, it couldn't write, and now I lost the 2 weeks of compute time. So here I need to talk to my colleagues. And the other thing I wanted to show you is that there is this long command. I don't remember it. I copy paste it from the documentation, but I use it if I want to find out where are all my too many files. And here you can see all my folders, but there are 99,000 files in this TMP. And if I go in TMP, then I can run it again, and I will see that 99,000 files are in Conda.
Just a comment. There is no need for you to rush, because you are now doing my job better than I can. So if you need 5 more minutes, it's fine with me.
Thanks. Yeah. Also, if you have ideas of what, like, unresponsible things I could do just to prepare better for for your session, I can try this out here interactively. But these were the most important things I wanted to show you. If we have a few minutes, I can show one more thing. I don't know.
Go ahead. I can do more lightly on some parts of mine, since you already covered it.
Good. So I want to show you one more thing, and before doing that, I will do something dangerous here. I will remove the Conda environment that I just created. And that's okay, because I have it documented somewhere else. And that will free up my space. Deleting. And then I will show you something about compute quota. Again, a popular mistake. But now it needs to now go through all these 100,000 library cards, find when they are, delete the files. So that's why it takes a little bit. We are here on a network file system. Maybe I'm testing our patience too much. I will abort it, Control-C. But I think I deleted enough files, because they are now, I'm not anymore in the red danger zone. I want to now go back into my example folder and show you another popular mistake really quick. I have a run script. Earlier today, we practiced how to submit scripts. And I will submit a very easy script, which will echo, let's go for a nap. Sleep for 5 seconds, and after 5 seconds, waking up after 5 seconds. And you immediately know what happened here. So this script does nothing more than printing something and sleeping for 5 seconds. But I can submit it as batch. Let's submit it as queue. Me, it's already finished. And there is an output. And in the output, I will find a lot of info here, but here we went for a nap, we waited for 5 seconds, we returned from a nap. All fine. But now let's make a popular mistake here. And the popular mistake is that I have something that really takes only 5 seconds, but I will ask it to run for 2 days on 60 cores, 64 tasks. Can I submit it? Yes. It's running? What? Surprise. How is it running? No. But why is the time 5 seconds? Okay, well, that's interesting. What I wanted, the point I wanted to make is that, well, let's submit it for more, 14 days and 256 cores. Submit again. Okay, so I exceed the time limit. But what did I want to show here? Time limit is it 1 week?
Yeah, for normal jobs, it's 7 days, something like that, I think.
I will try
Not sure.
30 days. Maybe
Yeah.
it's just 7 days. Let's try 7 days on lots of cores. I think you can see where this went to. I submitted it, but what I wanted to show you is that this thing will probably never start. It will take a long time to queue because now it's waiting for 32 compute nodes to become available because I asked for a lot of cores. I asked for a whole week. And the point I wanted to make is that this Slurm doesn't look into my script. It doesn't know that it will only need 1 processor. It doesn't know that it will only need 5 seconds. But if I ask for way too much, I will wait a long time in the queue. Maybe I will never start. I will also maybe prevent all of my colleagues in the project to start the job because I now removed 7 days times 24 hours times 1,000 cores. So 7 times 24 times 1,000 CPU hours from the account. Of course, then after 5 seconds, the job will finish. It will stop and it will return all of these thousands of CPU hours. But nobody else can submit jobs at the same time. So the responsible thing would have been...
You have a pending job on 172,000 hours on Scrum.
Yeah. So that was not responsible use, but it was good demo.
Yeah, and you can also see the reason when you ask me that why it is pending, probably node list.
So sorry, what should I comment on?
There are like reason, node list reason, associated grip building minutes. Have you seen it?
Oh.
That's one of the that's the reason of pending job. So
yeah. So what I asked for is so Espen found out somehow that it's really 100,000 or something CPU hours. But if I look at what is it that I have available, costs. Here I don't even, yeah, we had 50,000 available. I have now really overdrawn the quota. It's now heavily in the minus. This will never start. Nobody else can submit anything. Everybody else in this course is really unhappy at me. And how to fix it, I need to stop the job. Oh, sorry. SQ me as cancel. Let's cancel it. And now if I ask cost again, everything's good again. Relief. Everything got back. Everybody else can here submit jobs again. And I think I give, well, back to Dania. I don't know if there's more to say here, and then over to Espen.
No, there is not much to say, but we just can have a look into the questions. I think mostly everything is answered. Probably
and
the
I
last
remember
question.
that people wanted my history. I will paste it in there.
Paste it on the Q&A document. When we publish it, it will be here. Thank you so much, Radovan. And thank you for a good session. Maybe Espen, can you take over the screen?
Yes.
Yeah.
Thank you, Dania. My name is Espen Tangen. I'm a colleague of Radovan here in Tromsø. I've been working in the NRIS consortium since 2008 and have previous to that, I have a 10-year plus history as a user. Yes. Magnar?
I'm Magnar Bjørgø. I also work at the University of Tromsø, and I mostly work with GPUs and things related to GPUs like machine learning and AI. And I talked with Espen in the hallway about using shared resources responsibly, and he suggested I would join him for this chat. I'll try to monitor the chat, and I will do my best to be the new user asking Espen, interrupting him along the way.
Great. Just before we start, I want to comment on the question 39, because resources that haven't been utilized but asked for during a run are already wasted. So you can't get them back if you ask for too many cores and use not all of them during a run. You will be charged for what you have asked for and allocated, and not for what you actually used, unfortunately.
Really? I thought
Really?
it was the opposite.
Yeah.
If
me
you
too.
ask for, if you use one node, one core, and ask for 200 nodes on Betsy and Fram, nobody else can use it, and you have to pay for it.
So he's talking about when the job is actually running.
When the
Okay.
job is actually finished, yes.
But you
done.
don't get billed for all that time.
You don't get billed for the time you ask for if you don't spend it, but you get billed for all the resources that you have blocked during your exercise.
Okay.
So if I ask for, you ask for a full node and only use one core on Fram, nobody else can use it. However, we can get back to that later. Up until now, you've been presented to the specifics of HPC clusters very well, I must comment. But from a more technical point of view, my idea here is to present a more social side to it. Basically, the interhuman respect of sharing resources. And this is not because we think you're ignorant, but because by experience, we know that it might be experienced different inside a computer than similar situations in other parts of science, for instance, lab work, where you have security rules, security training, obvious consequences of maluse and resource blocking. But when it comes to computers, most people are used to having their own. Sometimes you basically forget that your session in a shared resource is not private. A supercomputer is a large machine, and this has consequences. Main consequence is that it is shared, which, as you know, induces expected behavior, meaning that you expect others to act in a certain way. We'll try to present this talk as more of a podcast back and forth. Please continue ask questions because they are very good. And also either you users, I suggest you users, participants on this course, address the questions in the markdown document. But Magnar, you have the responsibility to break in, and also others from the NRIS team.
Very good. I can, if you don't mind, I can just start with clarifying what Espen meant with the resources. So what Espen says is that So when the job is finished, you relent the resources you haven't used. But if you run a job, if you reserve 1 million nodes, but you only use one of the nodes, but you use one of the nodes for 1 day, you will pay for 1 million nodes for the full day. Does that clarify the issue that arose, or?
Yeah, let's
continue. But you had a really, yesterday when we discussed this, you had this really nice hotel analogy. So I was hoping we could start with it.
Yes, I will start with it immediately. I like to compare a supercomputer to a hotel. This explains very neatly, I think, the consequences of size and sharing. For a hotel is a huge house. It has, because of the size, it has multiple entrances. It has more than one check-in counter often. It has many rooms, obviously. Many alternatives for moving around, getting to places. It has many kitchens, but not necessarily in every room, and has often one or more restaurants. And this size has the following consequences, and that is services are often co-organized, like a kitchen. We have a lot less entrance doors than people living there, and the ratio is typically lower than for a usual house. Same goes with reception counters, which we can view as an example of the queuing system. Same with elevators and stairs, and all these areas are shared between all the guests. And going back to question 39, that will kind of mimic the situation where if you order 3 rooms and only sleep in one of them, when logging out the day after, you are expected to pay for all 3 because they are blocked for other guests. Yeah.
So we have login nodes, right?
We have login nodes.
And they can be thought as maybe the reception of the hotel?
Yeah, this reception area, the entrance area.
So it's a common area where we all have to go through.
Yes. I just want to say, have a quick comment on, because before we move on, there are 2 different means of sharing. You have the sharing, we have 2 different communities. That is everyone sharing using the machine. And that is, you also have sharing within your project group. That has been very neatly addressed by Radvan recently. But we also have 4 pools of resources to share. The easiest ones to address are the login nodes, compute resources, and storage. But we also have an issue with network bandwidth. I will not address that because it's somewhat more advanced. But I'll focus on login nodes, compute resources, and storage. Yes, if we view the login nodes as a hotel reception, if you block it somehow, if you carry all your luggage in and drop it in the entrance area, well, basically you deny people who do not need to go to the reception desk to enter. And the exact same thing happens to login nodes. We have a few on Saga. We have 5, but still there are about 1,800 users sharing. So if everyone do everything on login, you will deny people to enter.
So I think a nice analogy is that if you do something you shouldn't do on the login node, meaning you take all of the resources off the login node. It's like if you go to a hotel and there's a reception with 5 people working there, but you can one guest can start screaming and demanding the attention of all of the employees. And that's kind of what happens if you but I've done this. I didn't know better, and I would compile a software, and I was like, oh, I have 36 cores available to compile, or 128 cores to compile available, and I did. And then for some reason I get an email later, like, why are you using all of the login node? And then I was the guy screaming in the reception. And do you have examples of things that definitely? So sometimes we have to use the login nodes. Do you have examples of things we definitely should do on the login nodes, something we should sometimes do on the login nodes, and something you should never do on the login nodes?
Yes, well, another one has already mentioned some of it. There are some things you have to do, and there are some things you're expected to do. For instance, you are expected to log in. You're expected to do easy, quick installs, quick reading, writing, quick file editing, but and also some compilation you have to do on the login node, since the compute has a limited access to the network. It's not totally denied. For instance, GitHub is mounted there. So if you have a software project which is mounted or you download from GitHub, you can try from a compute node. Typically, what you do then is you ask for an interactive job, and when you get the resources, you check if you can download from GitHub. Yes, I hope that to some extent answered your question, Magnar.
Oh, no, it's very good. So what I sometimes do is I try to download everything I need, and then I figure out how to do the compilation in the login node, or even better, an interactive node. But once I know how to do it, I will write a job script. And the main benefit there are many benefits of using a job script. One is that if the compilation takes 3 hours, you don't have to actually look at the screen. So you also save yourself for a lot of looking at, you can do something more interesting than looking at your screen when you launch a job.
Yes, as a conclusion, we can say that as with a hotel, private stuff should happen only in private places. Login nodes are kind of and the reception area, kind of public areas. These are meant for file transfer, editing, job submissions, and for short tests. And as I said, some compilation may have to take place there, but not at all. And also, as Magnar suggested, downloading, transferring your files, necessary files to the login nodes, and then putting them into your project area and do the compilation, for instance, on a computer is a very efficient and polite way of using resources. Yeah, try to be efficient. I think it was mentioned in the transferring file session. It's a lot more efficient to put a lot of small files together in one large lump instead of doing one by one file transferring over. Efficiency is good. It's good for you and it's good for the community. How we can act responsibly towards queuing and resource allocation has already been discussed to some depth. Are there some things you think unclear about this? Please address it in the
At least I really like this. You have this table where you have this file area. So
yes, that's what I plan to jump to.
Oh, good.
Yeah. So I'll cheat a bit and put it. Do you see it?
I see it, yes.
Yes.
And I think everyone sees it.
Yes, because there are some aspects of this, these areas that Radovan did not mention. You need to be a bit careful when you put things on the machine. You need to have a careful idea of how it acts entirely, this file area of yours. So we have 3 different storage areas which you have access to. We have the home area. It's fairly, it's small. You have backup, meaning that if you delete some things by accident, you can re-find it elsewhere and get it back. The size is limited, as we have already discussed. You own it. That's an important point. You own it entirely, only you. You are the only person who have access to it, and it's shared to nobody else but you, and the cleanup is entirely manual. Radovan showed some procedures for doing that. Then you have the file area projects. It is large, can be up to 5 or 10 terabytes. It is backed up. It is limited in some sense. It's still large. The project owner is the owner of this project, obviously. And the access is shared within the whole project group. Typically for this group would be NN99. I could show you. If I do all my file area, you see here, all these files are owned by group NN9970K, which is the group for this project, for this teaching. It is shared within the group, and this sharing is actually forced. That's also important to be aware about. To be aware, sorry. It's
What
forced.
does it mean that it's forced?
Means that if you change the permissions to a file or a folder within your project folder, within half an hour, these restrictions are taken away.
But this also means that colleagues can delete my files if they want?
Yes.
Oh, so you have to trust your colleagues, basically.
Yes.
But is there backup on this?
Yes.
Oh.
It's backed up. This area is backed up. This area, the backup for this area, if you need backup, you have to contact the support personnel. The cleanup is manual. The project group, either the project leader or a dedicated person, or the whole group shares the responsibility for this. Then you have the work area, scratch area, temporary area. It's huge, has no backup, and it is not limited in the sense that it is not split into quotas. It's limited in the sense that, well, obviously we have a certain pool of disks, but it's very large. You own it, you can access it, you share it with nobody, but the cleanup is automatic. That is already addressed by Radovan. So this is important to basically to consider where you put your files when you do your jobs. And one aspect, a very important aspect, was asked by Magnar, is that, well, the whole group, all the members of your project can actually delete your files. Yes, Markin?
Yes, I wonder if there is a similar table in the documentation somewhere. Probably, or storage areas on clusters. Or is there more information in yours than And
Yes, it's gathered in a different way.
Mhm.
So this table do not exist in the documentation currently.
yeah, so maybe
You
we
want me
can
to put it-
make that
put it there?
available in the course material. That would be nice.
Yes, I can fix that. Yes.
So we think we have we covered the most essential things? I feel like we
think
forgot
so.
something, but
Yeah,
I can't
I
put my
think
finger on it.
so. It's I was taken aback by the amounts of intelligent questions from the participants kind of did the job for me. I think the point of this session is to provide a take-home message. This is a shared resource. Please use it responsibly. And what is responsibly, actually? I mean, rule number one, be efficient. That applies to your life, more or less, everything. And the technical aspects of being efficient has already been addressed elsewhere and by others. Rule number two is be careful about the logins. If you block the login, you block the entrance for others. And rule number three is do your production jobs on compute. And a typical pitfall has been addressed by Radovan already, but I can also show it here. If you do, I'll show the cast step run script here. As Radovan addressed, you ask for a certain amount of resources here, number of nodes, number of tasks per node. That adds up to 40. But on the lighter line, quite a few software need to start the message passing interface on the command line. So if you forget yourself and have a different number here than in the resource request area of the script, this one, the last one, takes precedence. So if you ask for one core, as the other one did, how much you allocate doesn't really matter. You only use one, but you will be charged for everything.
Yeah, so I think a good lesson is that figure out a way to, am I doing what I think I'm doing? I asked to use for 3 nodes. Am I actually using 3 nodes, or am I only running on 1 node? And this boils down to testing, and then if you're on a 1 node, you expect it to run twice as fast if you reserve 2 nodes. So if you increase the number of compute resources and you don't see a speed up, it's probably a sign that you're not doing exactly what you think you're doing. But that leads us to gives us a nice segue to the next section, because you can always ask for help. No one knows all of these things, but there is a very, very good support staff that can help with these things.
Can I just, I promised to try to address one question just before we wrap up.
Sure.
Was about the HPC working environment, a single user usage. Not entirely. I hope the hotel allegory have enlightened this somewhat. It's kind of both private and public at the same time. You have areas for collaboration. You have means for collaboration, but you also have things that you need to keep private, and it's your sole responsibility. And one of the things that were discussed in the previous section and earlier today is the purpose of module system. And I hope it's fairly obvious to most people then that we can't make everyone administrators. So we have to have a system for installing software in such a way that not everyone breaks everything else for everyone else. Yes, I hope that was a decent answer to that question. If not, please go back in the Markdown document. And as Magnus says, this is a very neat transition to the next session. Radovan, I guess the area is yours.
We will be, so the rest, it will be a presentation discussion. We have some slides and you can find them here. So if you want to follow along, they are also linked from the event page. So if you open up this link, let's see what happens if I do that. You land here. This is a bit zoomed in. And if you want, you can go through these slides, but we will share them. And please ask more questions, give comments. We will be watching this. We want to keep it really a discussion. The more discussion, the less slides, the better. It's also okay to ask questions about the previous topics, so don't hesitate. You can still ask about quotas and resources and software or any topics from yesterday. And I will now open up these slides. Hopefully it's readable, but if this is somehow too tiny, you can also open it up on your side. And we will talk with Rafael about asking for help with supercomputers, how to ask for help, some good tips on especially making your life easier. And by you, I mean everybody here in the audience as a user. We want to make it better for you, easier for you, so that you get the answer quicker. As a byproduct, it will also make our life easier, but that's not the most important thing. So in outline, we want to show you what different levels of help exist, and then discuss a little bit how to, when you send us an email, how to write it so that you get a quick answer, how to make it easier for us, and so that you get your results and can move on. And there, maybe we talk a little bit about reproducible examples. And it's really about improving your experience when solving issues. And I will just adjust here a little bit so that I can also see all the questions. Please keep them coming. What we present here, it is a result from many discussions, and there are some references to similar presentations. First, I wanted to discuss a little bit what are the different places that we look for help. I don't know, Rafael, where do you look for help when you don't remember a command or don't remember how was that again with Slurm and tasks and nodes per task and task per node? Where do you ask for help?
Normally, I use Google. Yeah, so pretty much I Google it. Like today, we are using a lot of ChatGPT, right? But I still use the old-fashioned Google. And also who uses Linux, most commands they have a built-in manual. So there is this command man, and it also explains a lot. Either you can use help, and it also gives a summary of how to use a command, and yeah.
Yeah, exactly. So a lot goes through web search and also AI these days, a lot of that. I also wanted to list that we have so-called Q&A sessions every month, I believe. We can maybe paste a link to those so you can come and talk to us in a Zoom room. In some of the places we have locally office hours where you can really come and talk in person. So here in Tromsø, we have that every week. If you have colleagues next to you who know more about Linux, and it's nice if you have them, but not everybody is lucky and has a colleague next door. And then there are things like mailing list, forum, Stack Exchange. I have tried to sort them a little bit with a level of scariness, because in some of these, if you ask a question, it's then it's then out on the internet. Not everybody wants to have the question out on the internet. And somewhere we have issue tracker. So this is we will come back to that. So when you send us an email on our side, it looks like it opens an issue or a ticket, and we have a system to track these so that we don't forget any, and we will tell you a bit more about that. When to ask for help? Yeah, don't hesitate to ask for help. Just don't hesitate. When in doubt, send us an email. We still like to see that you spend maybe a little bit more than 2 minutes, and I will hopefully demonstrate you why. That can be good for you and for us to think a little bit about the problem. So not immediately to send the email, because it can help to sharpen the question, and it can help us to be on the right track and to find the right person. We are many people in the organization with different expertise. So spending a little bit more than 2 minutes, but also don't spend days and days. Send us the email. Let's talk about it. And there is a question coming in. Thanks. I will look at it, but I will now switch to the next slide. Yeah, also maybe give yourself a time limit. I don't know, I will try for half a day, and if I don't manage, let's just go to the Q&A session, or somewhere it's called garage, office hours, and let's ask for help. Also, let us know what kind of help you want. Maybe you want an advice, or maybe you want us to do something for you. So be clear about what you want. It's good to know that on the other side, it looks like an email, and it looks like an issue tracker, but there is a human being on the other side. And we wanted to tell you a little bit about who is answering the questions, but also it's important for us to remember who is asking the questions. Because, so those who answer, so for us who want to help you, it's good if we remind ourselves every now and then that it's not easy to ask for help. Some people hesitate a long time before asking, because maybe they think that this question is too easy. Also, the person asking maybe has a lot less experience in Unix and command line than maybe 20 years less. It's good to remind ourselves always. It's not easy. It's not an easy thing. It can be a completely new thing. Computing is not maybe your main focus. Your main focus is research, and computing is only a tool. And maybe people have spent days or weeks on a problem, and so we need to remember that. We need to always be respectful. We try to do that. Also, those when the user asks a question, good for you to know that we have lots of colleagues, but we have a bit of a rotation. So next week might be a different person than this week. We don't know everything. We know often a lot about few things, but definitely not everything about everything. And sometimes I answer these questions, but I'm also not on the high-performance computing system all the time. I'm also doing other things, so I might not really even know some of these things. Sometimes the user knows better than I do. And we might not have context. So if you write without context, maybe I don't know the user. I don't remember what happened last week because I wasn't there. I don't know what the user refers to if it's not clear from the message. So to create this context is really useful.
Yeah, something that is said a lot of times. There's no stupid question. All questions are valid. So please ask questions. Don't be afraid. Don't be shy. I don't know everything. Radovan doesn't know everything. We usually help each other a lot. You can see on the tickets, but we usually ask in private messages for help for other colleagues. So yeah, and we learn a lot with the questions. So we teach, but we also learn a lot. And yeah, so please ask.
Yeah, thanks. Good point. It's scary. I remember my first ever technical email request. I was, I think, early PhD student, and I wanted something from a very like high profile person. So I wrote these paragraphs very respectfully, dear professor, but it was very unclear what I actually wanted. So the person had to read a lot. And then at some point I got this very short email back that I guess what you meant asking in between all of those paragraphs was, can I please get, I was asking for a specific code. And then I felt a little bit embarrassed because, well, I should have, the other person spent so much time on it. And over time, I learned how to ask more clearly what I wanted. So here a bit, some tips on creating this context and making a little bit clearer what it is about. So when you send us an email, the first thing that we see, so on our side, it opens this issue. Each issue gets a number. So they are all numbered. But then we see the subject line. That's the first thing we see. And then we can click in and open it up, and then we see more. But it's good if the subject line is descriptive. So if the subject line is problem, well, we don't really know. We have to open it up. It makes it a bit more difficult to immediately like route it to the right person, because it might, I think at any day of the week, we have 5 people working on support, and just to get it to the right person. And then we have maybe 60 other people who have expertise in this or that, and to get it to that right person. So here it might have been better to call the subject, why is my job crashing? Because here I can see, well, probably so it's crashing. And I have a bit of an idea what it might be about. So subject line, and more tips for context is username. What is your username? We can find it out, but through the email, but it's a bit tedious. Like we have to go to the databases, see with this email who was the username. So tell us the username. Tell us instead of maybe saying that the problem happens here in tilde/some path that refers to your home, and it works for you, but I don't know where your home is. I mean, this is a different place for me than for you. So instead, can be good to give the full path. And I see a comment, Espen.
Yes, very important email address. If you send support requests, please use your institutional email address, because we are also experiencing various types of hostile attacks where people pretend to be someone they are not. And we can't control Google Mail, we can't control all these commercial mails, but we do know that most institutions have some sort of pre-qualification for actually being a member of that institution, and also all the user profiles are connecting to these institutional emails.
Yeah, thanks. Thanks for this comment. Also, thanks everybody for the questions about costs and electricity prices. We might return to it, but this is really good that you asked these. And thanks here for the comment. Again, if we need to figure out your username, then institutional email is definitely better. Also, which machine? We have 3 compute clusters, 3 national compute clusters. We can find it out, but it removes some of the guessing, some of the back and forth. If it's helpful, tell us which software. If it's helpful, which research field. I'm not sure we have learned about this, but you can load certain, it is possible, technically possible, to load software automatically whenever you log into the machine. It's not a good idea, but it's possible. But if you do that, then tell us about it, because when I log into my home folder, I don't have the same environment as you. So if you use a automatic environment that is not clear from the script, tell us about it. And if you want us to look at your files, ask us to do that. We may have, some of the staff has theoretically permissions or theoretically the credentials to inspect files, but we just don't expect other people's files. So you need to ask for it. And then what is also useful, if something doesn't work, crashes, it's good if you tell us, well, has it ever worked? Is this the first time you try this? Or is it now suddenly not working anymore, but it has worked yesterday and the day before? That's really useful info. And also, what are you trying to accomplish? Not just the technical difficulty, but what is your goal? And we will maybe come back to that. Or what did you do? So if you try to fix it, if you try to diagnose it, or what were the steps that led you to this problem? So from login, when I log into the machine, I had to do this step, that step, that step, and then I saw the error. And tell us about it, because then we can go right away in and we can diagnose it. Otherwise, we have to spend emails back and forth to find out and read your mind. Like, what did you do? All right. Also, yeah, tell us what you have tried. Has it stopped working? Has it ever worked? This is sometimes not clear. If something fails, does it always fail this way or only sometimes? This can be difficult to answer. Some problems are random or they appear random. But if it crashes, it's good info if it always crashes this way. It always crashes at this point. Or you tell us that, well, this used to work for the last few weeks, but today it started crashing. Because then I immediately know that the problem is probably not in your script. The problem is possibly on the cluster. Something changed. Maybe one of the compute nodes is sick and needs to be replaced. What have you tried to isolate and simplify the problem? And I will have a little demo about it. Or should I switch to demo now? Maybe I switch to demo now. And that's just very quick. I will just switch to a terminal and show you a very typical problem and how you could do it better. Terminal, this one in gigantic font. Now I'm sharing a job script. Here we load some module. This is your favorite program, 2000 steps with a certain size. We don't need to know what's really happening. Now imagine that this is really your research program. And now I experience it crashes. I have a problem there. And what many people will do now is to write an email within 2 minutes and say that I tried this and it crashed, please help. But here you ask for 20 hours, 80 tasks. And maybe it crashes after 2 seconds. So before, what would have been maybe nice is to help can you simplify the problem and still get the same crash? If it crashes after 2 seconds, maybe we don't need to run for 2000 steps. Maybe it would have been enough to do 5 steps. And maybe to the size, whatever that is, doesn't have to be 100,000. Maybe 500 is enough to have the same problem. And maybe you see the same problem on 4 tasks and after 5 minutes. And yes, it takes a little bit of work to do this, but what was the advantage of this? The advantage is that now if you send me this example, it's much easier for me to help you because I will not have to wait. Like, I don't know your code. I don't know that it crashes immediately. If I ask for 20 hours and 80 cores, I also have to wait in the queue. We don't have any priority as stuff. So it will be tedious for me to debug it, to send it to the queue, wait 1 day, and then something was missing or it crashed immediately. So simplifying this problem can help you, can help us. And sometimes when you simplify the problem, you find out the answer actually yourself, because sometimes the problem simplification reveals the answer. I hope that was somehow useful what I showed here. So very, very typical thing. One thing I know now that I wish people that I learned 20 years ago was how to simplify a problem. It's extremely helpful. And I will switch back to the slide deck, look at the questions. And we have 20 minutes left, but including also Q&A and feedback. XY problem. XY problem is something I see also every now and then, which is I'm the user now. I want to do something X. I'm trying to do something. And then I do a bit of web search and I ask AI and tells me that in order to do X, you should do Y. I should do something. And now I try this thing and I try more and it fails. And then I send a help request to Raphael. So I'm trying to do something, please help me with it. But I actually never tell Raphael what is it that I really wanted to do. This is just in my head. I never told Raphael. And then we work on this problem and we spent a couple of days and we debug it and we figure it out. Or we don't, but that after some days we noticed that what was actually the problem? What did you really want to do? And at some point I tell Raphael, well, what I really wanted to do was this. But then we realized that was not the thing that we tried to debug was not even the best solution. There was a much better solution, but I never told Raphael what I really wanted to do. So it's good if this comes back to not only the technical problem, but tell us also the goal, because sometimes we know that there is a different path, and we can guide you to the different path. It also means for us as staff, it means that we need to read a little bit between the lines. If I get a question, I can try to just solve it, but sometimes I should read between the lines and see what does the person really want to do, and the solution is maybe not the question; it's something else. I don't know, Rafael, whether you had ever the experience as when asking or when answering. And sometimes we think we want to avoid this back and forth to save your time, to save the user's time. And we every now and then we think, well, should we have a form where people click, this was my machine, this is my username, this is the software I want. So the reason why we don't put a form in front of you by default is that we don't want to create a distance. We don't want to look like we don't like questions. So that's a bit of a worry that we have, that we really want to be approachable. That's why we will also not answer. So hopefully you never get an answer from our colleagues that just sends you here's a URL. Please read the fine documentation. We need to really start with empathy. We need to help show users how to do something. They might have 20 years less experience. Yeah, let's talk a little bit about what happens with a request. So on our side, it opens this ticket. Each ticket gets a number. Then we try to locate the person who knows how to answer this and how to solve it. Some of these tickets change hands because maybe next week I'm on vacation and then somebody else will pick it up and work on the case that I started on. That's why it's so important that we keep the context. And for each of these tickets, we have a thread where we keep notes and all the answers are there and somebody can read up and pick it up. And once the problem is resolved, then we close the ticket.
It's also important to point and to reply to us when a ticket is solved, because sometimes we ask the user, so we provide a solution and then the user never comes back again, and the ticket stays there open until someone asks the user, well, is it solved? And then sometimes the user answers, sometimes we still don't get an answer, so we close the ticket. But it's also nice to come back and give us a feedback. Maybe you solved by doing something we provided. Maybe you find another answer. So it's also nice to let us know if the ticket solved or not.
And since we have this discussion thread, if we are kind of still talking about the same problem, then please reply to the same email because it will help us on our side. It's still in the same kind of discussion thread. If you send a completely new email to support@nris.no, then on our side, it looks like two disconnected things. And then somebody needs to, zoom out and see that these two are related and somehow connect them. On the other hand, if we talk on a problem and we solve it, and then you have a different problem, then it's good practice then to send a new email. So because then it opens a new ticket on our side that makes it easier for us. And we have 10-ish minutes left. I wanted to look at 2 example requests, and they are really good. And we can discuss a bit why they are good and what we can learn from it. And maybe it's a bit too small to read, but I will read it here. So this is an email actually an email that we got, but a little bit modified. So I'm user so-and-so, and I'm on the cluster Saga. And since this morning, I can't log in anymore. I have tried to log in into Fram and Betsy, and it works. And the way I log in is SSH keys, and the error that I get since this morning is the following, some error. Thanks in advance. This is a really useful request. Why? What are the nice things about it?
The user is providing the username, the name of the cluster. The user also tried to log into other clusters, and the time frame when it started, and also a log. So what is exactly the error? But yeah, it's a very complete example, very complete request.
Really nice context creation. Like here, just looking at it, I will probably be able to solve it with 1 email in 5 minutes, because just from this email, I know that the user is familiar with SSH login. Probably nothing changed on the user side. From this, I can infer that probably there is a problem with a file and I know which file. I would look at that and I will tell it on one of the clusters. And then we can avoid these 5 emails back and forth and waiting. So this is really nice context creation. Here's another example, and maybe tiny, I will read. So I'm not sure I wrote it to the right support line, but what I'm looking for is a virtual machine where we can install a PHP, so some programming language, web server with a database behind it. And what we have in mind is to set up a service where we can share the data from our recent study. The data can be fully public, and it's about 2,000 records, so it's not so much data. And we would like to create a web front end where people can search through this research data and plot it. Looking forward to hearing from you. So what do you like about this request?
Also very complete, because the user is saying exactly what he needs, and the size of the request, and yeah, providing a lot of information, so we can actually tell the user if we have a perfect solution for him, where to start. So it's a very complete one as well.
Yeah, I like it too. So what I like is that there is the technical thing. This is when we come back to the XY problem, this is the Y. The user tries something, wants help. But I like that there is also the bigger picture. What is it that they really want? I also like that they say that data can be fully public. This is also useful information, because then I know immediately, this is not sensitive data. I don't have to think about, because we have services for sensitive data, but here I don't have to think about that. And I also get a bit of an idea of how much data that is. And the reason, and I will immediately take the comment question, but the reason why I like that they added this bigger picture context is that this is actually a real question, a little bit paraphrased, and we figured out that what they asked for was not the best solution in their case. So we ended up not doing this. We ended up doing something else, and they are happy, everything is good. But if they only wrote the first 3 lines, we would have implemented that, and we would have never known what they really wanted. Maiken. Or maybe, okay, there was a hand raised. Yes.
Yes, I just wanted to comment that one thing that also is nice about this example and the other is that it uses respectful and kind language. This is also something that's quite important when we reach out, both we as staff to the users and the users to us. Yeah.
Yeah, it's very important. And it's easy to not mean it badly, but I mean, everybody's busy and so are we. And sometimes it can, I mean, an email can read less friendly than it was meant. And we have to think about it. Really, we have to remember it. And there are emails that I have written and I regret it because it was all fine in my head and it was not meant that way, but it just felt distant and a little bit, dismissive. And now we are almost through. I wanted to give few tips on when you are maybe first time you try calculation or you move your calculation from one machine to another. We have users on our system who have maybe before they computed things in Sweden or in the UK and now they move their calculation to Norwegian systems. Every system is a little bit different. They are similar, but there are differences. And what I want to recommend is that when you start on a cluster and when you start something new that you don't know yet, or if you debug a problem, don't start immediately with a gigantic calculation. It doesn't have to be, I mean, I don't know, 16 node or not. Don't go directly on many nodes, many cores. First calibrate it. And it's like when we do experiments, like experimental research. If you do experiments on a particle accelerator, you will also first go calibrate it, start with something small, start with something that you know, and then you go for the real thing. And this also really helps. It helps us to help you. It helps debugging. It helps diagnosing. And it helps that we use resources better. So what I personally like to do is, even if I have a problem or I like to grow into a calculation. I try to start small, maybe on fewer cores, then more cores, short calculation, then longer calculation, smaller system, then bigger system. And the thing that can be surprising for people new on computing is that you don't have to start with a realistic system, because what I often hear is that, yes, I get it, but my system is the way it is because I need to do the whole DNA or something, and it's a lot of gigabytes and it takes a lot of time, and it would be unrealistic, unbiological, unchemical, unphysical to reduce the system size. But my point is it can tell you a lot about the calculation. So sometimes it can be useful to reduce the system size to something that is actually, from your research question, unreasonable, but you can calibrate your calculation. You get a lot of insight into how long will it take, how much memory, how many cores, and then you can scale back. Yeah, here. But a realistic system is big and takes long. Start with a synthetic example. Cut it down. That can help in debugging. It can help with the first steps. And once I get comfortable with it, I know exactly how much it will need, how much time, how much memory, how many cores, how it scales. And then I scale up. I go back to the realistic system. And that really can help a lot. If something doesn't work, it's nice for us if the example is reproducible, if you can reproduce it. Sometimes we cannot. There can be these random crashes and it's hard to do something reproducible. But if it's reproducible, if it always crashes the same way, if it always fails the same way, give us all the commands, give us all the steps, show us the run script so that we can try it on our side. Otherwise, we have to ask for it and wait, and then you have to wait, and we have to wait. Here, this is something I mentioned earlier as not a good idea. So don't put software dependencies into your bash RC. Bash RC is a mechanism, it's a file where you can do automatic things, and every time you log into the machine, they automatically get loaded. But it's not a good solution for software dependencies, because then it will work for you, but other people don't have these. And if you try this 3 years later on a different cluster, you don't have this either. So it's much better to put these dependencies into the job script. And then if you send us the job script, we see all the dependencies, and I can just run the job script and I can reproduce your problem and help. And then if you have these kind of small reproducible example, don't delete it, keep it, because next time your calculation doesn't work anymore, you can run this small reproducible example, and then you know, is this a problem on your side or on our side? And you can send us this small example and ask us to fix the machine. I think I will go to the last slide. We really like to help. If you need help with more the programming side, look for research software engineers around you. If you experience a problem, you are probably not alone. Don't hesitate to ask about it. Your question is definitely not too simple. It's definitely not stupid. And many people enjoy helping, so do we. You can also, from time to time, let us know when something is working. So in our job, we don't get too many emails when people just write that, well, it's working well. It's mostly emails about something not working. But it's from time to time nice to hear that things are working. It's pretty amazing that these really hyper complex, gigantic machines, most of the time they do work. And there are so many people behind it. But I will switch now to the document. Raphael, please chime in if I forgot something really. Let's look at the questions and at the feedback. Let us know about today. What was one thing that was really good? And one thing we should improve, change, remove. This is really useful for us to know, because in, I don't know, 6 months, we will do this course again. And then we want to apply these improvements. And this helps us to improve. There is also a feedback form for the entire course. Again, super, super important. This course is for free. The one way you can really pay us back is to fill out this form. So please do. Please click there, spend the next 5 minutes, fill it out. We need to know. That's the only way for us to see whether we are on the right track here or not.
Yeah.
And Tanya, how about you?
Yes, thank you, Radovan,
Thomas?
and yes, thank you. You can continue sharing the screen. So
Good. And thanks, Raphael.
thanks, Radovan and Raphael, and thanks to all the participants for joining and all the instructors who did a great job these 3 days. So as Radovan mentioned, I would like to emphasize to give us feedback for the day and also for the entire course. This is something we value for our upcoming events, and we really look into these feedbacks for the next events. I would like to announce a little bit about the training project. Those who applied for the project will have access until May. So you are free to test what you learned on Saga. So please do it. And on top of this page, there is a link to our upcoming events. And especially there is the 2 stage tools and techniques where Code Refinery and Day2 University we are partnering with this others, Code Refinery and team for an HPC workflow course. I think that would be the next one for you to go. If you're interested, that will be on every Tuesdays, 2 Tuesdays in April and in 2 Tuesdays in May. And please feel free to subscribe to our new mailing list from Sigma 2 and our sites. You will get notified whenever we have an event coming up. So I think that's all from my side, and thank you very much for your participation and also asking a lot of questions on this in collaborative document. That was super fun. And thanks to